In this video, we're going to talk about compound inequalities. The very first thing I want to go over is the inequality symbols. So the first inequality symbol is the less than symbol. The other one is the greater than symbol. We also have the less than or equal to symbol. And we have the greater than or equal to symbol. When you are looking at inequalities, we normally read the inequalities from left to right. So we can say something along the lines of A is less than 5. Or we can say B is greater than 1.25. Okay. We can also say S is less than or equal to a negative 1.28. Or we can say T is greater than or equal to 19.26. So whenever you are reading inequality symbols, we read the inequality symbols from left to right. The other thing that we do with inequalities is graph them on a number line. So for example, A is less than 5. We would do a number line. In algebra classes, we are used to constructing the arrows at the end of the number line that tells us that the number line goes to from negative infinity to positive infinity. In stats classes, we traditionally don't draw those arrows, but we do assume that they are there. So when we're graphing A less than 5, we start by putting 0 somewhere in the middle of that number line. We'll put a 5 to the right of 0, and then we'll use symmetry and use a negative 5 to the left of 0. So when you are graphing all the numbers, because that's what A represents, all the numbers that are less than 5, then we're graphing the numbers to the left of 5. Traditionally, when we're using a number line to represent an inequality, we use either parentheses or brackets. So when you are graphing and you have a less than or greater than inequality, we are going to use parentheses. If you have a less than or equal to, or greater than or equal to inequality symbol, you are going to use brackets. Okay. Because our first example, A is less than 5, has a less than inequality, we're going to use a parentheses. We call that the right parentheses for this particular example. We're also going to label the number line as an A scale. For this second example, B is greater than positive 1.25. We're going to start by constructing the number line. We're going to call that a B scale because we're using the variable B. We're going to put 0 in the middle, 1.25 to the right of 0, and negative 1.25 to the left of 0. And this inequality says B greater than 1.25, or all the numbers that are greater than 1.25. All the numbers that are greater than 1 and 25 hundredths are numbers to the right. So we're going to use a parentheses at 1.25 and then graph all of the numbers to the right of that parentheses. Let's go to the third example. S is less than negative 1.28. So let's say we have the number line here. And remember, we're talking about the variable s, so this will be an S scale. So we'll have an S scale. Let me move that up or make that smaller. So we have an S scale. I'll put it over here. And then we'll start with 0 somewhere in the middle. We'll put a negative 1.28 to the left of 0, and then a positive 1.28. We're looking for all of the numbers that are less than negative 1 and 28 hundredths. Numbers that are less than negative 1.28 are numbers to the left of negative 1.28. And because we are talking about the inequality symbol less than or equal to, then we're going to use a bracket. So we're going to use a bracket. So this region here represents all of the numbers that are less than negative 1 and 28 hundredths. And then we have a little more room here. Let's graph this. Again, we'll start with 0 in the middle. We have 19.26 and a negative 19.26. This is a T scale. And then we are looking for all of the numbers. We're looking for all of the numbers that are greater than or equal to 19 and 26 hundredths. Well, numbers that are greater are always numbers to the right. And we're going to use a bracket because we have greater than or equal to inequality symbol. We can also look at compound inequalities. So we can look at a couple of compound inequalities. So let's say we have negative 2.196 or negative 2 and 196 thousandths is less than A less than 1.456 or 1 and 456 thousandths. When you're graphing a compound inequality, what we can do is we can start with the number line and label that an A scale because the variable is A. We can add 0 in the middle, and then we can approximate our numbers. We have 1, 2, and 3. We'll have negative 1, negative 2, and negative 3. You want to make your number line as symmetric as possible. Well, in order for us to graph 1 and 456 thousandths, let's see where 1.5 is. And 1.456 will be slightly less than that, so I'm going to put it somewhere over here. So this is 1.456. Negative 2 and 196 thousandths will be somewhere over here. So now we are looking for all of the numbers that are greater than that is negative 2.196 and less than 1.456. Well, the numbers that are greater and less than the two numbers mentioned are right here. And because we are graphing, we're going to need either brackets or parentheses. So remember, the less than and greater than signs have parentheses. So we're going to include parentheses here. We could have compound inequalities with an open interval and a closed interval. Let's say we have B to be greater than 19.78 and less than or equal to 21.79. So I'm just making up a couple of numbers to talk about the concepts. So here we're going to start with the number line, the B scale, because the variable is B. We're going to add 0, but rather than adding it at the very beginning, we're going to put it here. Rather than adding it at the middle, we're going to put it at the end. So we'll put 0 somewhere there. 19.78, we're going to put it here. And 21.79, we'll put it fairly close because in comparison to 0, 21 will be somewhere over here. We're a little bit closer. All you want to do is approximate. So 21.79. So we have 19.78 is less than B. Because we have a less than symbol, we know it's going to be a parentheses. B is less than or equal to 21.79. And because we have less than or equal to, then it's going to be a bracket. And what this compound inequality is asking us to find, it's asking us to find all of the numbers that are greater than 19 7/78 and less than or equal to 21 79/100. The or equal to part includes the number. So your bracket is saying that the number in question is included. We could have compound inequalities that look like this. Let's say we have Z. Z is less than or equal to negative 1.96, or Z is greater than 1.96. So that's another compound inequality, and we're going to graph it. So when we graph it, we're going to add 0 to this number line, which is a Z scale. We're going to label 1.96 to the right of 0 and negative of that, negative 1.96 to the left of 0. And this is saying look for all of the numbers, Z, all of the numbers that are less than or equal to negative 1.96. Well, less than or equal to numbers are always numbers to the left. Because we have the inequality symbol less than or equal to, we know we will include a bracket. Or all of the numbers that are greater than 1.96. And numbers that are greater are always numbers to the right. The inequality symbol is the greater than symbol, and greater than symbol requires a parenthesis. Okay. Let's say we have a another example like this. So let's use a t-scale. So we'll do t is less than 1.875 or t is greater than 3.753, something like this. Okay, remember I'm just coming up with numbers so that I can talk about the concepts here. The scale here is a t-scale. The t-scale. We are talking about positive 1.875 and positive 3.753. So we'll include 0 towards the left of the number line. We're going to put 1.875 and 3.753 is approximately, not equal to, but approximately equal to twice this 1.875. So because it's about twice that number, we want to make sure that we do the twice the spacing, approximately equal to. So when you are graphing in stats, approximate numbers is okay. So we're going to put 3.753. What I don't want you to do is to put 0 here, 1.875 here, and then 3.753 somewhere way over here, because then it's not up to scale. So kind of like do an approximation to where the numbers are. So if we put 1 here, then we have 1, and then we have 2, and then we have 3 somewhere there. We have 4. You gotta just make sure you have some sort of scale. And then let's graph these inequalities. So we have t is less than 1.875. So you know it's going to be a parentheses, and we're looking for all of the numbers that are less than 1.875. We have t is greater than 3.753, greater than, it's a parentheses, and we got to shade all of the numbers to the right of this number. One of the things that we will be using inequalities for is to compare some numbers. So let me give you 3 numbers. Let's say I give you 1 point, so let's consider 1.645, 2.33, and let's say 1.96. What we want to do is we want to represent these numbers using an inequality. So if we want to represent these numbers with an inequality statement, the first thing we want to do is rearrange the numbers, the data values, we call them instead, rearrange these numbers from least to greatest. So from least to greatest, we have 1.645. Then we have 1.96. And then we have 2.33. So we have rearranged the numbers from least to greatest. And now let's include the inequality symbols. We say that 1 and 645 thousandths is less than 1 and 96 hundredths, and is less than 2 and 33 hundredths. So we have a compound inequality. Okay? So we are looking at comparing 3 numbers using a compound inequality. What if I give you 3 other numbers? What if we have negative, so let me write the instructions, represent the numbers using a compound inequality. I apologize for that background noise if you can hear it. So compound inequality. And I'm going to give you a negative 3.25, negative 1.96, and negative 3.99. So here we're talking about negative numbers. What I like to do, you might not need it, but I'm going to do it so that we can review a couple of things. What I'm going to do is I'm going to draw a number line and then plot these numbers on the number line so that I can then compare them. So we'll start with 0, negative 1, negative 2, negative 3, and negative 4, let's say. Negative 3.25 will be some number between negative 3 and negative 4, but closer to negative 3. So this number is represented by this blue dot, negative 3.25. Negative 1.96, well, that number will be between negative 1 and negative 2, but fairly close to negative 2. So we're going to put it right around here. Not at 2, but fairly close to 2. And then we have negative 3.99, and negative 3.99, again, it's going to be fairly close to negative 4. So now if I rearrange the numbers from least to greatest, we will have a negative 3 and 99 hundredths, a negative 3 and 25 hundredths, negative 1 and 96 hundredths. So we say negative 3.99 is less than negative 3.25, which is less than negative 1.96. And then what I'd like to do next, and this will be our last example in this video, I would like for you to consider this diagram here. This is a very important concept in stats. Right now for our class, we don't know what correlation or no correlation means. We're going to do that later. But what I want you to notice is that we have an R scale. So we have an R scale. And the R values that are greater than 8.25 or between 8.25, let me write it down. So numbers that are between 8.25 and 1 fall in the correlation region. R values that are between negative 1 and negative 0.825 fall in the correlation region. And then numbers in between negative 8.25 and positive 0.825, I'm sorry, negative 0.825 and positive 0.825 fall in the no correlation region. So we can do a couple of things with this. Let's consider R equal to 0.921, let's say. Does this R value fall into the correlation or no correlation region? Okay, so where does it fall? Does it fall in the correlation region or the no correlation region? Well, R equal to, and I'm saying R because it's an R scale, R equal to 0.925, well, that will fall into, let's say, somewhere over here, 0.921, right? And we know this because 0.825 is less than 0.921, which is less than 1. And 0.921 falls in the correlation region. We can think about negative 0.824, for example. Okay, so now same instructions. I would like for you to consider, so we're going to do a different one. I would like for you to consider R equal to a negative 0.824. Does this R value fall into the correlation or the no correlation region? Well, let's think about negative 0.824. You probably already know the answer, but I want to review a couple of other things. So does negative 0.824 fall here or does it fall here? So we are questioning where that falls into. So what we're going to do is we're going to compare those numbers. Okay. So we have in the positive, got to be careful, okay? So in the positives, we have 0.825 and 0.824. So if they are positive, then we have 8 and 8. They're the same number on the corresponding place value. 2 and 2, the same number on the corresponding place value. And now we have 5 and 4. So if we are talking about positive numbers, then we say that 0.825 is greater than 0.824. But please be careful because here we're talking about negative numbers. So if we are talking about negative numbers, negative 0.825 and negative 0.824. So because we are talking about negative numbers, we say that negative 0.825 is less than negative 0.824. And why is that? So let me go back to the graph, and I'm going to exaggerate a little bit, okay? So when you start with 0, you start with negative 1, negative 2, negative 3, and the numbers are becoming smaller as you go towards the left. Okay? So if we are talking about, sorry, I took a quick break because they called for my daughter's school. So I was talking about the negative numbers, and we were talking about what happens if we have a negative 0.825 and a negative 0.824. So if we come back to the number line, so negative 1, negative 2, negative 3, and you continue, okay? If we're talking about just whole numbers, a negative 824, so somewhere over here, a negative 824 is greater than a negative 825. Not the decimal part, but the whole number part. So when we are talking about negative numbers, and that is now back to negative 0.825, then negative 0.824 will be somewhere over here. Okay, I'll write it down. So we have a negative 0.824. And we can say that negative, over here again, sorry, negative 0.825 is less than negative 0.824 because numbers to the left are always less than. And then we can also say that negative 0.824 falls into the no correlation region. All right, I'm gonna stop right here. I'll post another video soon. Let me know if you have any questions on the video. Let me know if you have any questions on the concepts for the class. And let me know what you think about the videos, okay? I will talk to you soon. Bye-bye.